Okay, now we have all the things set up, so let's start with the topic. So, like I said, software quality, software quality and its measurement, or even more simplistically, software quality and how to define what quality is. But let's start with the quick recap on what we talked about last week. Not the administrative stuff, but the other stuff we were talking about at the latter part of the lecture. So a software system, regardless of the domain or in what context it's used, whether it's a game, mobile game, console game, or service, or whatever it is, it more or less looks like the same if we abstract it enough. So we have a system which has software parts which are made of components, which are made of objects, and these components discuss to each other, send messages to each other. The software components send messages to each other, and at the highest level, the systems send messages to each other. Of course, at some points, we might have hardware, keyboards, touch screens, mouse, joystick, whatever, sensor systems to provide inputs, and also other connections, internet connection, cloud systems, shared drives, databases, whatever you have, or you might have some resources which your system is using. So basically, this is all the software systems in the world. What these systems have in common is that they all have, of course, similar problems. The software aging problems are similar. The software maintenance issues, therefore, are similar. The software quality requirements or the programming work, programming tasks to create these sort of things are more or less similar, and that's why we talk about software maintenance as an entire area of software engineering. So, for example, if we are in acceptance testing, we already have everything available. We have the sensors, we have the inputs, we have the controllers, peripheral devices, we have client-side services, we have server clusters, cloud, whatever database we have. We also, in acceptance testing, already have everything available here. So basically, this is the stage on which we have to start to talk about on the software maintenance aspects. Because after the software has been accepted, whether it's internally put into web store, available for mobile phones, or whether it's given to clients for their use, or the first customers are brought in and they start using the new software or service or whatever we have. This is the stage when we have to start to consider about the maintainability, or, well, we should have talked about maintainability a long time ago, but we have to understand what we need to do to keep this alive. Keep this in a condition where it's sufficient enough so that the users pay money, or it's easy to use, or as easy to use as it used to be. It's competitive against our competitors. It has the features. It can somehow resolve the issue that the world moves on, and it needs to have new features, new possibilities, new configurations, and other things to address the ever-changing needs of our users. And of course, considering this from the more process-oriented perspective, we talked about the software lifecycle. So, okay, we start with the requirements analysis and specification. This is almost the cornerstone of all software engineering studies in theory. We specify how it should work, and we do design, development, and quality assurance work, usually in parallel, so that we get the system to work. When we have something that boots up, we start to do actual acceptance testing or actual testing towards accepting the product and putting it into operations at some point. And after we have done that, we have everything we have money, time, or intent to create. We have software maintenance cycle and the end of life scenario. Of course, on the last lecture, we were talking about the software maintenance in a sense that actually, even though it's only one step of the entire life cycle model here, it's also one of the most costly things on the software life cycle, because usually if the first development iteration, the first launch iteration takes something like 6 months, 1 year, actually the maintenance phase might take up to a decade, then even 10 years. And if you are in certain areas of software development or software industry, such as games, for example, there you have to keep developing new content and upgrades and stuff like that for your product constantly. So basically you don't even get that many cost savings, even if you switch from the first launch to actual maintenance and updates. Of course, even if you are doing something really traditional like point of sales systems or ticket management systems, you still have to do maintenance work to add new customers, new payment methods. If nothing else, then just create a tailored software for your new client. So we switch logos and switch around the user interface. Perhaps if we are in an international market, we might need to do some switches around the user interface, because on the Western countries, there's a certain standard of how the button layout works or the color schemes work. But on the other cultures, there's actually other set of default settings. For example, on some languages, you don't write from left to right and up to down. Or perhaps on some cultures, the green doesn't mean that it's success. It means that it's repulsive, vomiting, and the red doesn't mean negative, it's positive aspect. So these sort of tailoring things you need to do regardless of whatever you are doing. So on the maintenance cycle, you need to have a couple of developers on your payroll, and that costs money because it's actually a huge, long time frame to do. And of course, like it probably is obvious from the name of the course, we are focusing on this latter part of the things and expect that you have sort of an idea on what the first 6 items here are. Also, as a reminder, because this is actually somewhat relevant to this lecture, there's several different types of maintenance work. Of course, even if we develop our product further, create new features, add more content, whatever we do, we also have some other objectives. We might do some corrective maintenance, correcting errors, or as an emergency maintenance, do something unscheduled or emergency work to keep the system running or working. It also usually means that if we have to do emergency maintenance, we should have done corrective maintenance earlier, or at least it's the place where we are introducing rubber bands and bubblegum fixes to our existing system. Also, sometimes we need to adapt our software into new environments, platforms, hardware, software might change. We might want to upgrade or migrate our main development branch into a new set of new tools and stuff like that. Sometimes this is actually really huge stuff. For example, the Netflix decided on the without any sort of maintenance break on their services, decided to go from server cluster-based approach to container-based approach, so that you didn't even notice when they overhauled their entire technical infrastructure. Of course, this is something like once in a lifetime projects and huge things you need to do sometimes. But on the other hand, if you are the technical lead of your organization and you need to switch your entire system architecture or the hardware, the service architecture into something else, that's adaptive maintenance. Of course, It requires money, time, and resources, but it's still something that you might do on the fly, like Netflix did. Effective maintenance, on the other hand, is the adding new features. There's also a smaller level of that, additive maintenance. Basically, you just add things, add content, add options for the users to do something. They are more or less the same. The additive maintenance is the minor case of perfective maintenance. If we think about something like Duolingo, the language learning application, perfective maintenance might be something like adding an entire new language or new types of exercises or stuff like that. And additive maintenance would be something like adding modules to existing language, or small additional courses or themes or stuff like that. And finally, the preventive maintenance means that you increase the system's maintainability, stability, things that make the system run better. So, of course, that's also something you might want to do. So, this brings us to the software quality and quality in use. So, okay, we have different types of maintenance work. We have different areas we could focus on, or we could do different types of things. Our clients might expect different aspects from our software. So why are we talking about software quality? So these are the indicators of software system decay. So regardless of what domain we are talking about again, whether it's a mobile game or whether it's a embedded system or whether it's or production automation tools or office suite or whatever, you more or less see the same things happening again and again and again. So we get more frequent failures. The system simply isn't as stable as it used to be. If we go to look underneath the hood, we see that it's overly complex. We have been doing fixes over fixes over fixes over fixes, which means that it has become so complex that it's almost impossible to parse out what actually works and what doesn't. We are running in an emulation mode because we no longer have the directly compatible hardware anywhere. It's not a bad thing per se. For example, many of existing software systems rely on two-step compilers and this common languages. So basically, we don't the emulation mode or using a virtual computer or container or emulation something isn't that bad, but it's still a symptom showing that for whatever reason, if there was an original hardware or original compatibility for some system, it no longer exists. Also, very large components. The original design for the system has failed or no one no longer follows if we have these huge be-all, fix-all objects, classes, stuff which overtake activities or broke the structural design in a sense that everything is connected to everything, or that the objects, components are a huge ball of source code, which for some reason manages to create the correct outputs. And therefore, there's excessive resource requirements because the optimization is no longer a priority or thing. It's just something that we keep fixing enough so that it still works. We have deficient documentation, high personal turnover, and different technologies in one system. Of course, the two documentation and personal turnover things are more or less management. But on the other hand, who wants to be involved in a death march over a product that's going to fail at some point, or has to spend their effort trying to keep something alive that wants to more or less die on its own? Finally, if we have old enough system, there's different technologies there. So in a literal sense, it might mean that you have a hardware that has adapter to adapter to adapter to adapter connection so that you can finally have something quite relevant to connect. On the other hand, on the software systems, it might mean that if you try to maintain or fix or change something, there are several different programming languages, phases, basically software archaeology, which needs to be done because the original modules are from the 80s or even older software systems. This is actually, funnily enough, fairly common if we are talking about something that's really low-end Unix systems. Some stuff with the kernel or auxiliary libraries might be really, really old. So you never know if you are working with the source code or stuff that actually was written by your friend's grandpa or some other older person. And it isn't getting any better. I mean, we are so reliant on computers and computer systems that basically several things already are just new iterations of existing services. Meaning that in the future, if now we are in a stage that if you are a proficient COBOL and Fortran programmer, you might find yourself in a niche employment which pays fairly significantly better than doing some programming work. So, but in the future, there's actually a real possibility that due to existing systems being good enough that there's really no need to fix the core of the system, but only the user interface parts, there might be actually more use for software maintenance because we already have fairly fast internet and we already have fairly huge network of connections and we already have several services which can be used. But of course, going a bit further, not just guessing what might be going on in the future, there's a couple of themes which are fairly obvious if you start to think about it. First of all, there's the technical issues. The overly complex structure running in emulation mode and very large components, of course, are technical aspects. The hardware or the solution isn't that good anymore, so there's something that should be done. Also, there's management issues. No documentation or bad documentation, no one cares enough or no one has time or to do the effort and maintain or update the entire documentation or even run some sanity checks or do some pruning of excessive old documentation of the system or the project database. And there's a high personal turnover because it's not very good assignment and it's really laborious and unmotivating to keep working with the software. Finally, there's also quality issues. So there's frequent failures. The system requires excessive amount of resources to run, and there's different technologies in one system, meaning that of course there's bound to be a scenario when you need to fix something and you simply can't do it anymore. So technical, quality, and management aspects. Of course, these are more or less the three main problems you need to tackle with. Yes?
For the previous slide, different technologies in one system.
Yes.
What's wrong with having different technologies?
There's nothing wrong with having different technologies if you design around having different technologies. But if you have different technologies in one system because the older technologies simply no longer exist, so you have to just carve something out that is compatible with the older stuff. Because it's only a solution available, that's of course the problem. I know that even the old stuff .NET, beginning from basically .NET framework and the Java runtime environment, you could have several programming languages and several approaches and create different, use different programming languages or different approaches of generating modules which still work together. And that's fine if it's designed to do that. But if it's not designed to do that, then it becomes a hack hack job where you just put something in so that it stays alive and keeps running, and that's the problem. Yeah. But anyway, so these three things are more or less the problems. So that the process leaks brains, the documentation isn't properly maintained, the software is bloated, full of less than ideal fixes, and the system performance is weak. These are more or less all the symptoms of the software aging. The aspects I mentioned last lecture, even though the software itself is just lines of code. If we leave it on one file, it stays there, and it stays exactly the same throughout the years. But of course, because we have to do changes to the entire system so that it caters to our users, we tend to start having these problems because we try to keep up with the times. And this is more or less the problem. Of course, we are going to address all these things separately and together, and we start with the software quality. So, the first problem, of course, is that if we are trying to consider how can we improve software quality, is that problem that we have to understand what is the software quality. What is the quality we want to measure? How can we define it? Well, what's the way, what are the things that we need to do to actually understand what's the important part of the software system? Of course, we already know from the bachelor's degree courses that there's several different ways of measuring stuff. There's measurements and metrics. And there's also the saying that if you don't measure, you can't manage. So what do we want to measure? How can we say that something has declined too far? What's the point where we need to actually do the maintenance cycle to fix some issue? And of course, this means that we have to identify what we want to fix. So, starting with high quality. If the product is still high quality, there's no real need to fix it. On some occasions, some people might argue that, for example, certain models of iPhone or Nokia, older Nokia phone headsets and stuff are so high quality that basically you don't need a new version of the system, you just need one with a fixed battery pack and enough computing power to run a modern mobile operating system in it. But still, that's just one case in several. For example, certainly definition of high quality game is different than definition of high quality Medicare system, certainly. And the problem isn't just that, even within the one domain, even if we focus on one thing, like text editing software for the one operating system on PC. The problem is that if we interview 10 people, ask about high quality, of course we get 10 different answers. And this is actually something that we observed when we were doing a research project where we assessed how well the ISO IEC 29110 and 25010 standardizations for software testing and quality assurance and software quality and the software quality definitions match with the real life organizations. Are they even useful in a sense? We found out that actually even people who work on the same product do not agree naturally on what is high quality. If we ask them to pick three most important features or characterizations of quality for the software they are working with, they do not tend to pick the same ones naturally, because everyone is thinking about the quality from their perspective. They might, in some organizations, think about what the organization is trying to achieve, but of course this means that the organization has to define what is the quality that they want. The person doing software systems development, programming, has their own set of priorities. person doing the user interface design is having their own priorities, and person running the project has their own priorities. And they don't have the same definition of high quality. So it of course means that there is no absolute high quality. If you want to have a definition of quality, you need to make one, and if you want to have some quality you want to measure for software maintenance needs, you need to also define that one. And also, considering that we don't have the infinite amount of time or resources or money or personnel or whatever, you also need to sometimes consider the two, for example, the two things that can a product with a faulty design be of high quality. Of course, one could say that if we consider the old Eastern Bloc Soviet cars, they are horrible compared to global new cars. But on their own markets, they were very good cars. For example, the Lada from the 80s. It's, well, the driving experience is that it's a self-propelled thing that allows you to go from one place to another, and it's not very comfortable ride, of course. And it's also somewhat bad design, there's faults in it. But on the other hand, the engine starts on every weather condition imaginable. There's not enough electronics in the car, so that them not working would actually mean almost anything, and so on and so on. So some people might say that it's not a very good car, but on the other hand, some other people who find that it's easily fixable, it's durable, it starts provided that you can heat it up enough. And stuff like that might say that it's actually of relatively high quality. So it has its faults, it has its design problems, it has mechanical shortcomings, but it's overall relatively of high quality. You always know that when something goes wrong, it's cheap to fix. It's something that you can do on your own garage. Same with several other cars, and also obviously several other products. On the other hand, if you have a product which keeps failing, can it be high quality? If we are continuing with the automotive analog here, for example, Audi has huge amount of programming problems, huge amount of electrical problems, sensor problems, stuff like that. But no one argues that Audi isn't a high quality car. Similarly, if there's something, if you buy a Ferrari, well, if you have enough money to buy one, then congratulations. But still, consider that they have production runs of from a couple of cars, a couple of hundreds of cars, to a couple of thousands of cars if they are doing some mass production thing. And they keep failing, at least on a higher rate than several other cheap used cars, so to say. For example, the Dacia Sandero, or whatever it is called, in other markets, it's cheap car, it's mass manufactured, and it, well, isn't very high class or high performance car, but definitely it has a lower fault percentage than, for example, Ferrari. And there was a Ferrari car which had an annoying problem that if you run it on certain weather, its rear brakes might caught fire. It puts the tires on fire, and if you don't notice that, it burns out the entire car. So, okay, you have a sports car which sets itself on fire if you drive it on a hot enough tarmac. So, is it good quality or high quality? Of course, it's high performance car. It's very nice looking car. It's someone's dream car, but unfortunately, on a very hot summer day, it sets itself on fire. So of course, it might not be of high quality on some level, but it might be high quality on some another level. Or if you buy a car which you can drive legally on a normal road because it doesn't have all the all the necessary lights and other things? Is it high quality car if it doesn't even function as a car? So considering all these, there is no high quality. But there's a couple of definitions for quality, and we don't even have to go for the fringe cases of talking about old Soviet cars or Ferrari, which is more or less specialized product anyway. There's Garvin's definitions for quality. I'm not absolutely certain, but I think that the Garvin paper, which gives a longer definition for all these, is on the project, on the course Moodle pages. If it isn't, then you can easily Google around. It's very informative paper to read. So first quality is transcendent definition. So the first definition for quality is actually that you can't define it. You have something in your hand, you intuitively know if it's good or not, if it's high quality or not. Well, it's one definition. In Finnish, it's more or less called perstuntuma, but in any case, it's the quality that is something intuitively understood. But of course, that's not very useful for us. The product-based definition is that it's the quality is the components and attributes of the product. So if we have high quality products, we have high quality components, we create from those high quality product which performs well, has low rate of failure, and so on and so on. So if we want to enhance our quality, then we get better components and more performance out of it. Also, user-based definition. It doesn't matter what the level of components are or how it performs if the customer doesn't like your product. On the other hand, if the customer likes your product, then the product has good quality, regardless of how awful some of the subsystems are. If we keep going with the automotive analog here, this is the 70s and 80s British cars. Made from completely horrible components, but still some of the cars were considered very good quality things because they were nice to drive when they work, and so on and so on. More. So going from the sum of components or user satisfaction, the manufacturing based. If the product conforms to the design, it is good quality. Of course, this doesn't take into account the idea that is the design correct, but if the product actually follows the design to a letter or fulfills all the requirements set by the design, it's of high quality. Of course, we can immediately argue that if we designed a wrong product or are missing some key features, it's not as useful as it should be, so it's not high quality for the user or customer, but for manufacturing, it's high quality if it conforms to design. And finally, combining a bit of all these things, if the product is perceived as providing good value for the price, it's good quality. So if it's good enough or better than you would expect or stuff like that, then it's probably good or high quality because you get more than you would expect to pay for to get for that money. And of course, going further, because that's only for the products we are developing. Of course, we also have components, we have parts, we have services which are combined to each other to create something that functions and gives us ability to do something. If we go from the products to services, it's even more crazy because we don't have the definition that, okay, we have a product, you do something with that, it's made from this and this and this, and this, the quality is either on the components or the parts or the user expectations or stuff like that. If we are talking about services, there's also several other things. For example, if we are using software over a website, is it even a software anymore, or is it a service that we are providing by a browser. Or if we go think about something like an online food service. What's the quality? Is it the food? Is it the delivery? Is it the payment? Is it the variety? What the customer can expect? What are the places where it works? And so on and so on. So of course, and if we are running a online food service, if we have bad restaurant in there, which provides bad food, so basically a food poisoning on bike or on wheels, is it our service which is bad if our customer orders spoiled food over our service? Or how does it affect our quality if our vendor or third-party organization is actually providing a faulty product? So all these things matter, because it also means that if we are running a service, we have to have some way of measuring or assessing, for example, our third-party services and or things that are really not on our control, but we have to be aware of them so that we can perhaps design or circumvent these problems somehow. For example, if a restaurant gets enough bad reviews, then they are out of our service system. On the other hand, if our product is a fountain pen, we more or less know what we want to do with it. But on the other hand, if you want to make a high-end pen, which sells for 5,000 euros in an airport store, Mont Blanc pens, for example, and we can select if it's a gold or platinum or whatever the outer casing of it, or some exotic leather or stuff like that, or if we are aiming for something like this is a plastic pen on which you can write for the one day, and then it breaks down or runs out of ink or stuff like that. Of course, you more or less have an idea on the expectations and the requirements and needs. So, regardless of if we have a product or service which we are trying to define, there's a couple of levels of quality identified by Björn Regnell and the research group from Lund University, our cooperation university, by the way, which defines some levels of quality for the benefit of use, or in this case, software maintenance. So, there's 4 levels of quality. Of course, useless quality, it's pretty self-explanatory. If you don't have enough quality, your product or service is useless, and that's the end of it. It doesn't work, it isn't cheap enough, or it doesn't function well enough. But of course, if you invest on your product quality, you at some point reach the stage of useful product. It of course means that it's a viable alternative for your competitor, but on the other hand, you still have to invest more money to be competitive. Meaning that these are the organizations or products which are more or less capable of stealing customers from other organizations. And finally, you can also go to excessive quality. You no longer benefit from adding features and stuff like that, because your customer already gets what it wants, and most likely your further investments on your software quality or software maintenance work would be wasted or money thrown out the window simply because there's no real need for doing more work than necessary. Of course, you need to keep in mind that unfortunately, even though we are engineering people, more is always better, and faster is always better, and so on and so on. When we go to the real world from the university, we have to live with the fact that we don't have infinite amount of money, like I mentioned earlier, So at some point, there is no reason to invest on more on quality or software processes or having more developers or testing cycles and stuff like that. Because finally, this is of course highly theoretical, almost something that's from the business school courses, so sorry about that. But still, if we need to consider that if we don't invest on the maintenance, if we don't invest in the quality that much, we will end up using huge amount of money on fixing things. On the other hand, if we do testing cycles, quality assurance work, and that sort of stuff, we also can use huge amount of money on that, on test automation, on artificial intelligence-based neural network, test automation robots, which of course would be able to do almost anything but are hideously expensive to create, and so on and so on. So most likely there's a nice midpoint somewhere where we get enough quality to fulfill all our customer needs, fulfill all our maintenance needs, and still not actually waste money going with the excessive quality. Of course, where this point is of course always related to what your project is, what your product is or service is, what's your competition, what's the stage of your product, what you are trying to do. Are you trying to attract more customers? Are you trying to just keep the customer base you already have? Or are you doing some mandatory maintenance or upkeep work because you have a contract saying that this service has to exist until the end of 2022, and when it's the 1st of January 2023, you are laughing manically when you are pulling the plugs from the system, because that means that you are not using any money on the maintenance unless you really, really need to do that. So, most of you probably have seen this at some point of your studies. This is the, well, not perhaps this, but the ISO IEC 9124, which is the predecessor of this model. So basically, this square model, software quality definition, means that the software and system quality is defined by these characteristics. There's one for products, one for services, and for both there's one for the thing itself and in-use model. So basically, it means that there's this list of characteristics: functional suitability, performance, compatibility, usability, reliability, and so on. And on all these characteristics, there's smaller definitions. For example, for the performance efficiency, there's time behavior, so responsiveness, resource utilization, so level of optimization, and capacity, meaning that how much can it do on a certain level of resources. So all these things are defined so that you can, for your convenience, for example, define what are the important ones from this list, what are the important characteristics, what are the important sub-characteristics, and how they can be measured. Of course, on several things, especially on the in-use model, these things are up for debate, or they are preferences. So in several cases, they are just ask the customers, but it's still something that tries to give you ways of measuring different things. But this, on the other hand, wraps around with there's no common universal high quality, because we use that model with our software organizations. We did almost 250 assessments of what is important for the different organizations. And well, first of all, only in 9 cases out of 250 assessments, some participants said that, in my opinion, this characteristic isn't important at all. So meaning that all these functional suitability, reliability, performance, operability, security, so on and so on, are at least a bit important, regardless of what your software organization is doing or in what domain they are working. Also, because it's perceived quality and there is no absolute quality, you might consider that something like transferability isn't really that important. So you are working on one platform, you are providing your services for one system or two platforms, which are Apple system and the Android system. And basically, that it wouldn't be as important as, for example, security or reliability. But considering that we did the assessments and we didn't get really strong results, transferability was the least important, but it still was considered somewhat relevant, whereas reliability and functional suitability were considered very important, but not not with that large margin. And of course, if we consider the in-use usability, so how nice it looks, how well it behaves, how much resources it uses, then we have completely different set of rules, meaning that it's probably even worse there. And if we go, for example, from the different software systems and services, the organizations we interviewed for these things were more or less industrial automation or online service providers or organizations doing an application for some real serious use. If we go into games, for example, we are dealing with completely different set of things, because with games there's no inherent use in the product. The use of the game product is to get preferable user experience, have fun, or get the user experience you want to have, because of course playing horror games isn't fun per se, but it's the thing that you are expecting to get. So it means that everything is different. And for example, on that area, there's also some new or different set of things. For example, with games, on mobile games, the sessions tend to be long enough that they are significant user of the battery power on your mobile phone. So one competitive edge, for example, is to do really good optimization work, because then the system runs leaner, uses less power, and you can play longer. It runs smoother, your phone doesn't heat up, or it doesn't eat your battery, so it's a competitive edge. Play our games, you don't have to find a battery recharger after every game session. And this, I can really tell you that this is actually something that Rovio did for a long time. They didn't want to have Unreal or Unity engine programmers. Well, they did. But they also wanted to have people who are hardcore C programming language optimization specialists, because they needed to have their games running leaner, smoother, and more optimized, not only so that they can cram more complex things to their products, but because it also allowed them to run the same types of games much leaner or smoother than the competition. So you could play the Angry Birds games or the Bad Biggies at that time longer, and you didn't get the irritation that after half an hour, 45-minute game session, your battery is dead and you need to find a recharger. So you could play the game on bus or trains. Well, the trains now have sockets in them, but at that time they didn't. So these are all different types of competitive edges. And these are all different types of ways to understand that if you are looking for a good quality, or in software maintenance perspective, trying to find competitive edge or something that your design has to do, it might not be apparent just by looking at the paperwork. So, okay, so here is the quality in use characteristics. I'm not going to spend much time with this because I already talked about it quite extensively. For example, in the quality in use, efficiency, effectiveness, user satisfaction, freedom from risks, stuff like that. They are, of course, important. Of course, if we are talking about games, we are talking about satisfaction. But on the other hand, satisfaction itself isn't just usefulness, trust, pleasure, and comfort. It's also efficiency, like mentioned, because it allows you to have longer sessions or allows you to have more complex games with limited resources, so your pleasure from using the product gets higher because the efficiency is better. Meaning that even this international standard isn't absolute truth. It uses equality in combinations. And if you want to look more details, this standard can be found on the last draft version of the standard, which is basically almost word to word the same with the official release standard, but unfortunately we can't share you the official standard documentation, but we can share you the last draft of the paper. Don't ask why, it's licensing and legal issue, but because we are involved with the design of the standardization, we are allowed to show our students the drafts of the standards, but not the final versions of it, unless you have personal license or your organizational license to use that. And I'd venture a guess that you don't, so you will have to look the drafts I've put online. But anyway, of course, this image or figure is, well, not very good because it's a bit of a mishmash of everything. But basically, it tries to tell you that the standardization for the software quality looks almost for everything. So product quality model, data quality model, and quality in use model tries to understand the quality from several perspectives. We are a bit behind on the schedule, so I'm not spending much time with this. But for example, if we want to consider what are the parts or important things to look for in quality, there's the software itself, of course the data it's handling, there's the operating system, there's the hardware part of the system, the usability aspects and all the other things. So it might not be a parent thing you need to do. And if you are looking for some ways to measure how some characteristic would work, there's actually a list of things. This is an example from the standard itself to measure how to measure time efficiency or cost effectiveness. Of course, by themselves, they don't mean that much. But if you are in a contract or trying to negotiate or set or define some ways of measuring or for the definition of your software product quality, these might be useful for getting the message across that these are the things we need to measure so that we can define what we need to do or fix in the future. So, okay, so this is the high-end part. So, okay, we have several definitions of quality. We have a standardization for quality. We also know that from the organizational perspective, people don't necessarily agree on the what is the high quality or what is the quality they need from the software. So let's look a bit more at the more practical level. So considering that we are working in a software project, this is regardless of even if we are doing the first iteration or if we are doing the 5th iteration or nth iteration during the software maintenance cycle, there's a couple of more, surprisingly more new definitions on what you could actually expect the quality to be. There's a naming definition that the quality is conformance to specifications. And if you get the specs right and build according to them, this is how world works. So of course we all know that this is the basic waterfall model, and the world doesn't work that way. So it's not very good definition. Also, but the naming isn't completely wrong with this definition, even though there's the get the specs right, and that's the first part of the sentence is already faulty. But the other part, you cannot inspect quality into a product. It's actually quite important. So regardless of what we are doing in software maintenance, we usually can't fix things that are broken by design. So if you are working in a project where you already have inherent fault or major shortcoming in the original design of the software, you probably can't fix it on the software maintenance. So you can't expect the maintenance crew to fix those things later. Similarly, most problems, whether it's the original design or if it's the design or fixes or patches or stuff like that later, they are more or less caused by the process or the organ you are following. No one probably wants to do a hatchet job on the fixing things or put a bubble gum or a rubber band code to keep everything together. But unfortunately, usually the organizations aren't willing to pay enough to fix things properly, because they consider the downtime, they consider the problems, and even if you try to improve the organization, it's in a sense that you try to introduce new tools or new working methods or new approaches to something, or try to automate something. The organization, of course, might acknowledge that it would be beneficial, but they don't want to do it. Because it costs money, it's investment, it's out from the productive work, and it's always a risk. And you don't fix something that isn't broken. So these problems might actually show up also if you are trying to do something like fix product which isn't completely broken. And that's also why the preventative maintenance isn't very well-liked approach. Well, of course, considering the quality theme, your own approach is that the quality is fitness for use. So it means that how good the product is from the perspective of the user. Of course, this is more sensible. I mean, the people who are reliant on the software, people who have to use the software, of course, what they think that they would need. Is the user interface simple enough to use from their perspective? And also, how do we measure that? Do we have surveys? Do we try to see how much time people spend on the website? How much time people spend on the website before they manage to add something to their basket or stuff like that? These are, of course, are all the measurements or in a tangent on a related family of measuring usability. Of course, high usability is usually a measurement that the quality is good, provided that the system under the hood or behind the front end is actually working correctly. So with this quality definition, it's fairly easy to agree. Also, some other things on quality. There's Pareto, who is also famous for the diagram, trying to assess why things fail. There's usually the problems accumulate to certain parts of the system. They all usually accumulate to certain parts of the system so that if you identify the problems, the small number of areas or parts which are problematic, then you will probably have found the areas you need to fix first. This is something that's also taught in the object-oriented programming or in the fundamental software engineering methods and modeling course. That usually there's a couple of components which are more complex than others. And usually more complex means that it's more probable part causing problems. Then of course, this means that you need to find the complex parts, but luckily for you, there's measurement ways to assess the complexity of source code, and we will go to that in the near future. And finally, for example, with the Toyota, eliminating all waste. So just in time, manufacturing quality made perfected from the definition of carbon. So everything happens exactly when it needs to happen. You need 5 screws to fix some component to your car. You get that component and exactly 5 screws when the part comes to you. So, but of course, this is just a way of how quality is done in real life. So, taking this into real life. So, is it always that good process means quality product? I'd argue that it doesn't. Of course, this is very heretical to say for me, but even if we have excellent software engineering process, it doesn't mean anything about the product quality. Usually, we use process models so that everyone knows what everyone is doing, who is responsible for what needs to be done before this product is completed, what we should be doing now, what we should be doing next, and so on and so on. But that's all it is. It's not meant to be a rule book or dictate how things are done correctly. It's more or less approach which implements people to understand how the entire organization works. And if something doesn't work for the process model, then you just throw it away. The implementation in each organization needs to be something that works for that organization, not the other way around. I have seen and actually worked in places where they started up new committees just because the certification said that this needs to be done so that you can be a highly functional organization. Adding 50 more, well not 50, let's say 20 more assigned roles to the different levels of administration because some German rule book said that this is how you become a good organization, making everything a fucking mess on the run. So don't do that. So good process means that you have something that usually works. But it doesn't mean that you always release good products. It just means that you are not causing extra problems by having a undefined or badly working ways of doing things in your organization. So, going even a bit further, there's actually a research that the developer practices, the 2 key developer practices which support quality outcome, meaning that the program probably isn't as faulty as it could be, or at least it's at the best quality level possible with that skill set and that amount of resources, money, time, and so on, then they are version control and testing work. If you lack one of them, you are doing something wrong. But if you are a professional developer, these are the 2 things that has to work so that you can even get good enough quality so that you can get something you can maintain, you can get something that you can actually release, and you can get something that you can manage. So basically, running a version control isn't difficult. There's only a handful of rules, which there are. So one change at a time, don't break the build, don't ever commit something that makes the build fail. Commit only one source code at a time, use log, who did, why did, what was added, what was removed, so on and so on. Of course, you don't have to write it by your own hand. You can also use a system which shows the difference between the files. Most of these well-functioning version control suites actually do that automatically. But if you are, for some reason, trying to run a version control that doesn't have that feature, then you should probably look for another tool. And communicate with other developers. So the entire version control exists so that you can do managed parallel work. And if something fails, you can revert to the earlier version which still functioned. That's more or less the reason why it exists. So these are more or less the reasons why the activities with the version control you should be doing. Also, if you are doing agile work, this is a list of additional things that you should be doing while you are doing version control. This is also something about the testing work, or quality assurance, or what you should be doing when you are doing a development work, whether it's for the first launch or for the software maintenance cycle. So keep your project releasable. Okay, we already talked about that. Automate acceptance testing, use automated unit tests, provide useful error messages, write code to be clear, not clever. This is actually something fairly important. You might consider that someone being funny and writing a source code in a December that looks like a Christmas tree is nice addition to your product, but it's actually really fucking horrible code to try to fix later on. And of course, you don't need to show all your fringe knowledge over how the C programming language manages memory or stuff like that if you are trying to make something that's readable and understandable by other people. If you are a skilled programmer, you can, or hacker programmer, or capable of doing whatever you want with some programming language, it's a nice thing for you. But unless you really need some fix or something to work like you made it, to be clever, write understandable, clear code. Because someone, somewhere, at some point probably needs to fix that code or make changes. So if you use some really esoteric approach, then it's hard to fix later on. If you want to be a complete bastard with it, then why don't you then you might as well already write the entire source code block with a brainfuck programming language anyway. So write readable, not clever code. Also, of course, have code reviews, stuff like that. But these are more or less collection of things from a survey about agile practices and what approaches are something that's really useful. Something that you should look into or try to adapt in your organization because they have benefited the organization combined with the version control approach. So whether you are doing software maintenance or development. And of course, if we compare this to the software testing certification ISTQB, there's only a handful of things that are different from this. So testing only shows that there's still bugs in the system. It never shows that the system is free of them. So of course, test early as possible, defects cluster, there's a test. Testing is context dependent. If there's no errors, it doesn't mean that there's no problems, and pesticide paradox, meaning that if you fix all the problems of certain degree, then you will no longer see those problems. So of course your automated unit tests always succeed because you fixed all the problems, or you are only observing those possible things, but still there are problems in your system. So of course these, especially considering when you are automating your testing work or automating regression testing or automating unit testing, it's easy to fall into the false feeling of safety, saying that we have a huge library of software tests and they keep succeeding, so our system is free from problems. No, it only means that it's free from the problems you are observing. There's probably always something wrong, at least when you need to change the hardware. And that's why software ages. No matter how large your unit test library is, you need to do some low-level or platform-related changes which will introduce problems to your system. And if you are someone who's trying to find where the problems are, this is a list collected from our Intro to Software Engineering course. Of course, this time in English. So, new code, new feature, new technology, changes, last-minute changes, imported code, made for new client or new domain, or made by new employee. So, if you want to focus on finding the problems, then you probably have to look into these parts or try to use some complexity analysis tools to find the parts which are most probable causes for the accumulation of problems. And this means that the 80% of the faults are in 20% of the components, or if you are doing software maintenance work on the legacy system, it might be that all the problems are caused by the new module because it tries to use the system some way that it's not meant to function. Okay, so this lecture about software quality and in general how you should understand the software quality so that you can measure it and or define it or how to maintain it with your software development practices can be summarized as this. So if there's only one thing you need to remember from this, try to remember the effect of measuring and managing software quality and compare it to what the general maintenance needs are, or what are the sort of types of maintenance projects or maintenance cycles, and how could you use quality definition or quality measurement to select your next maintenance cycle objectives. Of course, if you are working as a developer or are kicking up a new project, the version control and agile practices mentioned on the last slides are also useful. So if you are defining something new or designing on how you're going to do software development, those might also be worthwhile for you. So, the first self-study assignments are now online. Go there, go to the Moodle pages, check them out. You need to, or you can submit one of the two possible works. There's one a bit more technical, with, I think it was XUnit framework this week, and there's also essay approach. Do whichever you like more and submit that one. You don't get extra points for doing both, so select which one you want to do. I have a consulting hour. It starts at 1 on the room 2518 to the top floor from the Indian restaurant near the street cafe. And of course, if you submit your work, do it via Moodle. This spring, this course has 35 students. Of course, this isn't 35 people, as you might observe, but there are several online participants. So everything will be handled via Moodle. I will not read or open or create email submissions. If the Moodle is down, then you can try to send me something via email. But if the Moodle is working, then I will just delete your email submissions. This is simply because I want everything to be at the same place, because I also need to do the comparison between the different submissions so that no one is cheating or trying a freeload. Go as a freeloader through this course. And also register your project group. So I have one group which has registered for their open source project. It's already added to the discussion forum. Go to the Moodle pages with your project group, and on the separate discussion forums, which is for the project reservation and later on for distributing the presentations, make a message as shown by the example to reserve your topic and reserve your open source project. If someone else takes it before you, then tough luck, select something else. On this course, we do not allow several presentations on the same topic, although last year we had 2 presentations from the same editing software, but that was due to administrative error. So go to the course website, register your project group, register your topic, and go check out the weekly assignments. Okay, that's that. We'll see next week, and otherwise, well, have a nice rest of the day. Go have lunch, whatever. We're done here today.